Hey guys, I'm going to do chapter 3. I also noticed I didn't do number 36. I think I did that in class with you guys, so I'm just going to make sure you guys got it, number 36. And then the questions for chapter 3. Okay, so if we look at number 36, depending on the class, we did this one together, and that'd be 30, right? 8, 58, 14. So if we total those up, all right. All right, so it says, according to the two-way table, what percent of the males, so of the males, only thinking about these 58 men, what percent of the males had their first crush before 13? So that would be these 11 and these 2 were before 13. So what we'll have to do here is add these up, giving us 13, over the quantity 58. And we notice when we divide that in a calculator, we get our answer C. So this is definitely a question we worked on in chapter 2, and we got a lot better at when we started to do chapter 5. So hopefully you feel comfortable with that. All right, chapter 3, 26. I did this one in period 3, but not period 4. So let me explain my notes here. It says there's a linear relationship, which tells us that this is the equation of a straight line between fat and calories. And the least squared regression would be a line of best fit. So we should be kind of thinking in our head that if we graphed fat and calories, that the more fat there is in a certain food, probably the calorie intake would go up as well. And all this is doing is making a line of best fit. Okay. It says X is fat, which is why I labeled that there, and Y is calories. We also know that we predict Y. So we could actually, if somebody told us how much fat was in it, we could use this graph to predict how many calories we would have. But it's not really asking us to do any predictions. It's asking what is this line of best fit estimating that the calories would increase for an increase of 8 grams? So as we move up the table 8, how much if this increases by 8, how much would that increase? And that's our slope, right? So it tells us that the slope, which is the number in front of the X, is our change in Y over change in X. So it's the amount of calories we would change for every 1 gram of fat we would add to the food. So we notice these are kind of equivalent fractions. If this is true, then how many calories would there be for 8 grams of fat? And we notice we can just multiply that number by 8. And when we do that, we get our answer C. So question number 26 is dealing with a linear equation and identifying what does it mean when I apply the slope to the problem. All right, question number 30. So we go to question number 30. We see it says the equation of the least squared regression line. So here's another least squared regression line. What is the residual for 0.3, 4? So we notice that this is our line of best fit, right? And the residual is how far off is the Y if the actual Y is something from that predicted. So if we look at a coordinate here, this is our X value and this is our Y value, our actual Y value. And the predicted value is what comes out of we can figure out what would the line of best fit predict where it would go. And so if we use this, we can solve. Our X value here is 3. So if we plug this in for 3, we end up getting 4.31. So again, the residual formula says my residual is equal to my actual Y value, which is 4, minus my predicted, which is what I get from plugging into the equation. And notice I get a negative 0.31. So if there was a line of best fit, which there is, this 0.34 is beneath the line of best fit. It was less than we would have predicted. We predicted 4.31, but we only got an actual value of 4. Question number 40. It says sales of jelly and sales of peanut butter are recorded weekly, and they find that the correlation is 0.9. So again, I just make a quick graph so you can kind of see if I know how many jars of jelly I sell, would I be able to kind of predict the number of jars of peanut butter, and would that be positive? Oh, excuse me. So it looks like it will be because the correlation is a positive number, and R here is 0.09. We also know that R squared is 0.81. So we notice that the definition of R squared is actually right here. 81% of the variability in X, the variability in Y can be explained by a linear relationship with X and Y. That's actually the definition of R squared. So that's why we picked this one. Now you might be thinking, well, what about if I interpreted the correct interpretation of R? The correct interpretation of R is Duff's. That's when we're going to say there is a strong, because that 9 is a big number, right? Close to 1, strong. Positive, because that number is positive. So that's direction. Direction, S for strength, there is a strong positive. Linear, that's form. Relationship between X and Y. Peanut butter and jelly. So if they wanted to tell us what the correlation means and we're using R, this is what I would be looking for, and I don't notice that in my problem. So these other ones are just distractors. This wording is correct, but notice they use the number R, not R squared. All right, nice work. Check out the next video for the next chapter.